So part C says the surface area of the exposed water is changing at a rate of 9 pi cubic, sorry, not cubic, centimeters squared per hour when the depth of the water is 4 centimeters. So we know the depth is at 4. At what rate is the radius of the exposed water changing at this point in time? So we need surface area. So surface area of on top of the cone is 4 pi r squared. And so we take the derivative of that equation. We have 8 pi r dr dt. So we know the height, the d is equal to 4 centimeters. I gave you guys a hint. Radius is equal to what? 1/2 h. So therefore, I will take that and substitute it into r. So then your equation becomes 8 pi in parentheses 1/2 times 4 times dr dt. So that is what your expression is going to look like now. Okay, so from there, you have everything you need. You already know what ds or dA dt is because it tells you right here, 9 pi square centimeters per hour. So that's your rate of change of the area. So again, I am recording this, so I will post this up. There's also something else I wanted to go cover. I think it was the problem on this one here. I may have made it slightly more complicated only because I didn't realize that you weren't going to be able to find dx dt. But because at that moment, if x is fixed at a constant rate of 4, so you really look at this, whatever trig function you decide to use. Let's say I decide to use sine of the angle is going to equal to, not sine, I'm sorry, cosine. I can use cosine of the angle is equal to y divided by 5. Or I can use tangent. Either way, tangent of the angle will equal to, in this case, since this is equal to 4, it is 4 divided by y. So if I look at this, I'm really looking at just coefficients in the situation. So this would be negative sine theta d theta dt equal to the derivative of y, which we know is dy dt. But since it's divided by 5, I just have a coefficient of 1/5. The same thing with this guy here. We know it's secant squared theta d theta dt equals to, this is on the bottom, so we know this is going to be negative y negative 2 dy dt times, obviously, times 4, right? Because we have a 4 right there. Excuse me. So if this is a positive rate of change, 3 radians per minute, as this angle is getting larger and larger, obviously what's happening to y, it should get shorter and shorter. So that's why there's a decrease. That's why it should both be negative. So either way, it should work out. So these two expressions are actually going to be fine for you. So I actually kind of made it a little bit more difficult for you guys last time because we went through quotient rule, which is all correct. Everything we were doing correct, but we made it more complicated, especially the way I led it, because I just realized, wait a moment, it didn't say dx dt was changing at a rate. It just wanted me to know what dy dt was. So, and this would actually be a multiple choice problem, so it wouldn't take you that long to do. It shouldn't take you that long to do. So either way, I can either choose this method or that method. Both should give me the same answer. All right. Okay. So this is your review. Pretty much, I'm going to develop your exam over the weekend. the question should pretty much look the same. Like you've got 5 questions here, but on the test, you'll probably have 8 multiple choice questions, and you'll still have 3 free response. So the 3 free response are big points. They're probably going to be anywhere between, I would say, a minimum 4 points apiece to about 8 points apiece, and that will give you the bulk of your grade. So I get the chance to see kind of like what your work was and what your logic is. So keep your answers simple and straight to the point, logically explaining what you used. Please reiterate some of the vocabulary terms from the question, as in when it's asking you how fast is the top of the ladder sliding down, in your question it should say the ladder is sliding down at a rate dy dt equal to, for example, that sort of thing. At what rate is the angle between the changing? The rate of the angle d theta dt is changing at. Do you get what I'm saying? That's kind of like a good, quick, good explanatory statement for you. What I am giving you hints and clues about is that if you see 3 parts to an FRQ or 2 parts to an FRQ, that's exactly what you're going to see for that type of problem. So these FRQs are pretty much exactly the same on the test, except for maybe this function is a little bit different. Okay, but like 7 and like 8, you're going to see exactly, except they're just going to be different setups with different like numbers. And then this one here will have a totally different function, but I'm asking you the exact same thing. Okay, so that's why I really wanted you guys to study this and do well on this review. Again, remember this is equal to 0 because I forgot to do that. Okay, so that's pretty much all I have to say right now. Are there any other questions that you guys have for me about this review, since we're just kind of doing a work day? And I feel like I just ran a marathon right now talking. Okay, I'm gonna just go ahead and pause for a moment right now. So I don't just record dead air recording here. Going back to, where is this? Here we go. So I look at, oh, this is it. Sorry. Oh yeah, here we go. If I look back at, look at your schedule for today. Remember that we meet up 4th period at this time, 1:15 to 4:30. So on Tuesday, you only have 2 classes. Each day you have only 2 classes. That's only classes that you should be in Zoom meetings with, for the most part. So the test will be turned in by 4:30. I don't want to wait till Friday, guys. This is ridiculous. Okay, I don't want to wait. Hopefully by Tuesday, I have like 99% of all your grades up to date by this moment, as some of you are starting to turn in stuff little by little, like here and there. And I told some people that if you do well in the exam, you're going to do well in the class. Like if you haven't done much at all this year, I'm not going to give you 100 just because you got 100 in the exam, because it's very hard. It's very hard to do that. It's very hard to just see like how well you guys did. And then everyone else who's worked so hard has to turn in their work on time. And then those who all you have to do is just show up for a final and all of a sudden get 100. Yeah, it's just remember that. Okay, guys. So if you did well and you haven't turned anything out, not because of situations that have impeded your progress on that, but if you do well, then yeah, you'll at least pass. That's for sure. If you've been turning in all your assignments, if you've and under extenuating circumstances that have again impeded your progress throughout the year, because obviously some of you have talked to me personally, and I do know what's going on with you through like other staff members who have alerted me about what's the situation going on with some people, then that's a different situation. But for most people that haven't done much of anything and haven't come to class, well, your final exam is your one last shot to just at least get like a 70 or a 72, something like that. That's kind of give you a ballpark area, which you should be getting. Okay. But again, we'll be here on Tuesday, 4th period. Your exam is due by 4:30 p.m. Okay, let's get that in, because what that means that you've pretty much got all that time to do that. You have 3 hours to do that exam. It shouldn't take you that long to do. And again, like I said, if you're doing the review and with the hints I've given you, you should be doing well with this. It should not have a problem. Okay, I've already got 2 videos now, this one and the one I gave to you last time, so it should help you guys out a lot.